Hello, Assalamualaikum. Have a nice day. We're going to try to solve problem 3.3. This is actually 3.3 for Atterberg limits, and it deals with the liquid limit and the plastic limit problem. So we have in here the given, the following data shows the result of the liquid limit and plastic limit tests. So we have the data here, there's a table. We have the test number, the number of flows, we have the weight of wet soil plus container, and the weight of dry soil plus container, and the weight of the container. So we have here in the plastic limit, the test number again also, and then we have the weights for the wet soil, dry soil, and the container. So same as with the natural water content or the in situ water content. So we have two tests for the plastic limit and the two tests again for the natural water content. So we're going to solve in here. Number one, compute the liquid limit. Number two, the plastic limit. Number three is the Li. We can add some Ci or the consistency index. Number five, we have the flow index. And then we have also number six, we have the PI pala dito first. Going to solve for PI first. Solve for the CI. Then we have also the flow index. And add up with the toughness index. Okay, so we're going to solve first for the liquid limit. For liquid limit, we need to solve first the moisture content of the four tests. Then we can have the data for the moisture content and we can plot it later with the semi-logarithmic graph to determine the liquid limit. So we're going to solve first for the test number one. So we can follow the equation for the moisture content, that is the weight of the water all over the weight of the soil or dry soil, and then times 100%. And then let's try to solve the test number one with the number of flows of 35. So you can see here the values for the number of flows is decreasing as it tested with many times. The one sample of soil tested many times for the liquid limit, you can notice the decreasing number of flows. So for test number one, what we're going to get here first is the weight of the water following this, and the weight of the dry soil following this, and the moisture content in terms of percent. In terms of grams. So from the table here, we have for test one, we have 22.46 minus the weight of the dry soil plus container, that is 19.44. This is equals to 0.02. And then we have the weight of the dry soil, that is 19.44, minus the weight of the container, that is 12.76. This yields a value of 6.68. So for moisture content 1, let's denote this one as 1, or moisture content 1. So we have 3.02 divided by 6.68 multiplied by 100. This is equals to 45.47%. So this is our moisture content for test 1. For test number 2, there are many ways to solve this one, the moisture content. You can tabulate it or you can solve it this way. So weight of the water, let's check the table 2. We have 21.33 minus 18.75. 21.33 minus 18.75. So this yields the value of 2.58. And then we have the weight of the solid, soil solid. We have 18.75 minus the value there for the container, that is 13.06. That is equals to 5.69. And for the moisture content 2, this is 2.58 divided by 5.69 times 100. This is equals to 45.34%. So this is our moisture content for test number 2. For test number 3, so we have the weight of the wet soil or weight of the water. So we have 21.29 minus 18.78. This is equals to 2.51. Weight of the soil solid, have 18.78 minus 13.26. This is equals to 5.52. For the moisture content 3, we have 0.51 divided by 5.52 multiplied by 100. This is equivalent to 45.47%. So this is for test number 3. For test number 4, so we have weight of the water. Let's take a look. 26.12, 22.10. So we have 26.12 minus 22.10. So this is equals to 4.02. And then we have the weight of the soil solids. We have 22.10 minus the weight of the container. That is 13.27. So this is equivalent to 8.83. So the moisture content for number 4 is equivalent to 4.02 divided by 8.83 times 100%. This yields 45.53%. Okay, so we have 4 moisture content already. So we have 45.53%, and then we have here 45.47%. Then we have 45.34 and 45.21%. So you can notice that the values are in terms of 45% with the varying decimal places. So as the number of rows is increasing, you can see the moisture content is this list, 45.21, and compared to the moisture content here. So So the moisture content here is increasing as the number of loads is decreasing. Okay, so we can plot this at semi-logarithmic chart.